Hi again, this is Professor Eckhouse talking some more about section 1.3 rates of change in behavior of graphs. As it turned out, it took me long enough that I stopped after this first topic right here. So I looked at finding the average rate of change of a function, and now I'm going to look at the behavior of graphs, which is these next two topics. Okay, so we're going to start by looking at increasing and decreasing, and then we're going to look at local extrema. So what we're looking at here is the graph of a function. So the function, it's always nice to know what the function is that you're working with, just so you can kind of get familiar with these functions. And this one is f of x, or remember that's also y, equals x cubed minus 12x. Okay, so this is x cubed minus 12x. So this is a cubic function. So just take a look at it, just, kind of think about, is it symmetrical, is it rotational symmetry, that kind of thing, and it is. And then there's some notes here about increasing and decreasing, which we're going to talk about. So let's think about what this means, increasing and decreasing, okay? So as we move across the x-axis from left to right, okay, so that is the important part that you need to understand, is you're moving left to right as we discuss these things. So when we say something's increasing or decreasing, we're talking about as we go from left to right. Very important to understand. Okay, so remember one more little piece of terminology is moving left to right means we are looking at the input. Looking at the input as the input increases. So the input increases going from left to right. All right. So first let's talk about what's happening here. So this thing is increasing, right? As you go from left to right in this section to the left until you get to this top point right up here. And then nothing is happening. It's not increasing or decreasing. So think about that. And then it's decreasing until you get to this next point where nothing is happening. If I drew a line here, which is called the tangent line, that is going to be horizontal. It's not increasing or decreasing. Okay, then it starts increasing again. Okay, so we're going to use this information to talk about the local, or it's also called relative. So relative and local are the two words that we use. Those are the extreme values of the function. These are the places where the function is constant, not increasing or decreasing. Okay, so like I said just a moment ago, this point right up here, the top, is a place where it's neither increasing or decreasing. Neither one is happening. Down here, at this point, same deal. It's not increasing or decreasing. Okay, so those are considered local extrema. It's where the function is constant. So since this is math, we have to have actual definitions. So the local maximum, the plural of maximum is maxima. So if there's more than one here, we would say maxima, but there's only one. The local maximum is where the function changes from increasing to decreasing. Okay, so it changes from increasing to decreasing. So that's what we're going to write here. I'm going to write increasing to decreasing. And we have to make sure it's clear that it's as the input increases. In other words, as we go left to right. All right, the local minimum, or minima if there is more than one, is where it goes, the function changes from decreasing to increasing. So these are terms that you really need to know and understand what's happening here, because you're going to be asked this a lot in math. So make sure this is clear. So the way you'll be asked to explain this or describe it, you'll be asked to say where the graph or the function is increasing, what interval it is increasing on. Okay, so that's what I've written right up here. Increasing on and decreasing on, and we want to put an interval. Okay, so the increasing interval is going to be this one here in blue and this other one here in blue. So it's increasing in two places. So it's increasing when you go from negative infinity to -2, and it doesn't include 2 because nothing is happening there. It's neither increasing or decreasing at -2. And then it's also increasing in a different place. So we're going to say union with, and the next place is right down here at +2. So we're going to have union with, and it does not include +2 because it's not increasing or decreasing at 2, up to infinity. And we always put a curved bracket at infinities because infinity is not included. Okay, so where is it decreasing? So it's decreasing in between. So decreasing right in here. So decreasing is happening between -2, not including -2, so we use a curved bracket, up to 2. Curved bracket again. Okay, so on this example, we're supposed to find very specifically, it says finding increasing and decreasing intervals, but the actual question says identify the intervals on which the function appears to be, and I'm going to highlight it, increasing, where it appears to be increasing. So we're going to look at, I'm trying a new color here. So it looks like to me, it looks like it's increasing from 1 up to 3. And then it decreases until it gets down to around 4. And I'm just going to call it 4 because it's hard to tell. But I think around 4 up to positive infinity. Okay, so we're going to write both of those with a union sign in between. So we've got going from, and remember we use x as our interval. We're looking at the input. So from when x is 1 up to when it's 3, union with from when it's 4 up to infinity. Okay, the next example asks us to graph a function and then use the graph to estimate the local extrema of the function and determine if the intervals on which the function, determine the intervals where it's increasing. So they're specifically asking us to do increasing. All right, so I would like to show you guys how to use Desmos if you have never used it before, although actually I think at this point in the semester you probably have. But we're going to go there and we're going to use the graphing calculator. So just to do plain old graphs, you just click on graphing calculator. I have already logged in. I use it all the time, so I have an account. I recommend having an account because you can save your graphs. So if you see over here, I have a lot of graphs that I have saved over the last few years teaching and just doing math. So we are going to go back to a new, we're going to go back to this graph here. I'm not going to save it. I don't want to save it. All right. So we've got this function, f of x equals 2 over x plus x over 3. So I'm going to you don't need to write the y equals or the f of x equals if you don't want to, unless you have more than one function and you want to give them different names like y1, y2, or f of x, g of x, that kind of thing. And that's for a little bit more advanced things. There are reasons to do that, but not right now. So if you just say divide by, it puts a fraction bar. And then I'm going to hit the right arrow, and I'm going to hit plus, and then x divide by 3. All right, so we get this kind of crazy graph here, and I'm going to click this hide expression list so that we can see the whole thing. If I use the roller, the little wheel on my mouse, I can scroll out and in. So we're looking at where this thing is going to increase and decrease. So there's a lot going on here because there's two parts to the graph, so we're going to have unions on this. So I've got increasing happening from negative infinity all the way up to wherever this point is. And once you click on this, notice that these 2 points have shown up. And that means that's the maximum. Okay, so it just automatically showed up when I clicked on the graph, and that is the maximum and this is the minimum. Okay, so that's going to help us to figure out where it's increasing and where it's decreasing. So you would say that this is increasing from negative infinity up to negative 2.449 and from 2.449 up to positive infinity. That's where it's increasing. All right, it's decreasing when you go left to right in the other two parts. So now notice there's an asymptote here, so be careful. You can't just say from negative 2.449 to 2.449. You have to say from negative 2.449 up to, looks like it's going to 0. Yeah, looks like 0. Up to 0 and not including 0. Union with from 0, not including 0, up to 2.449. Okay? So increasing negative infinity to the point, and the point to positive infinity, decreasing from the point to down to 0, and from 0 to the next point, but not including 0. So there's a union in both sets. Okay, so back to our problem. I wanted to go ahead and write that down for you so you could see it. Negative infinity up to negative 2.449, union with 2.449 to infinity. And remember, the point itself is not included because that is the maximum or the minimum. So there is no change happening at that point. So if you decide to do this on a graphing calculator, you can do that if you would like. So this, I believe, is a Casio, and this one over here on the right is a TI graphing calculator. You can look up on YouTube how to graph things on your calculator. Okay, so local or relative maximum and minimum is what we've looked at so far, or extrema. Now we're going to look at absolute maximum and minimum. So we look at the graph's entire domain to find the absolute maximum and minimum, the entire domain. Now remember, sometimes they can be given to us on an interval, so they may have endpoints. Another word for absolute is called also global, and you'll see that online if you look things up. So absolute and global mean the same thing. And so what we're looking at here is a graph of a parabola that has an interval. So it only goes from -1 to 2. So there is an absolute maximum right over here at f of 2 equals 2. So f of 2 equals 2. There's an absolute minimum at 0. In other words, f of 0 is -2. Okay, so you may be asked to tell what the function value is, which is the y value. So make sure you pay attention to the question. All right, can this point over here be a relative or an absolute? No, it's not absolute. It's neither maximum or minimum. It looks like it might be a relative maximum, but endpoints cannot be local extrema. It's so important that I'm going to write that down. Endpoints, if it's on an interval, cannot be local or relative, is another word for that, extrema. All right, so important. I'm going to put a big red box around it. So this is your final problem on this, and instead of working it for you, I'm going to have you work it and answer in the interactive video. So the question is finding the absolute maxima and minima from a graph. So for the function f shown in this figure right here, find all absolute maxima and minima. And I just wanted to point out that this says absolute, okay? So that's not relative. So give that a shot. Okay, so hopefully you tried that problem and were able to figure out the correct answers. The absolute maximum happens at -2, so let me put a point there. -2 and at 2, because they are the same. They're the same height. They're both at 16 here. So that means there's 2 absolute maximums. There's only one absolute minimum, and that's right here at 3, which is 3, -10. This would be considered a relative minimum, but it's not an absolute minimum because it's decreasing as you come from the left and starts increasing afterwards. So that's considered a minimum, but it's only relative. All right, that is the end of this section. Thanks for watching, and be sure and get in touch with me if you have any questions at all.